Today on Tech Talk, we're going to talk about SCA. You know, the three scariest letters in radio. No, it actually means Subsidiary Communications Authority, and what it was a way that FM radio stations could generate extra revenue by selling some extra spectrum that they weren't using. This has been around for years, still in operation today. Let's take a look at how it works. Today we're going to talk about multiplexing, and specifically how multiplexing was applied on the FM broadcast band. And most people, when they think about multiplexing, think of FM stereo. I'm going to try and draw this out to try to illustrate what we refer to as multiplexing. So first, you have to understand that if we look at our FM carrier, I'm going to draw, this is going to be crude, but I'll try and draw this to make some sense. So we've got our spectrum, and here's our center frequency for our carrier. We'll say 100 megahertz just for simplicity. Now in North America, now I know in Europe it's different, they're on 100 kilohertz channel spacing. In North America we are on 200 kilohertz channel spacing, which means that if you have if your frequency is 100.1, the next channel that can be used would be 100.3, and then 100.5, etc., etc. We have 200 kilohertz spacing. Now, your audio spectrum only uses about 20 kilohertz either side, give or take. Actually, your FM is limited to about 15. But here's our audio spectrum. Our audio spectrum goes like that, approximately, plus and minus 15 kilohertz. This is the audio bandwidth I'm referring to, not the deviation. I'm going to draw this a little bit bigger, but this is to give you an idea. So here's our channel spectrum, and of course our next radio station down would be 99.9, right? I'm drawing this like this so you guys get the idea, because of course if this station here also has their audio, and this station here has their audio, etc., right? This is the spectrum. So you need guard bands in between so that the stations don't overlap with each other. And this other station here would have its audio over here, right? So this gives you an idea how the spectrum is laid out. So what we're looking at now, this is the baseband. So on the very left of the screen there, that would be your carrier. And going from the carrier center frequency all the way to 15 kilohertz, that is your audio for your left plus right, or your mono audio. Now the deviation is 75, I think it's 75 kilohertz for an FM broadcast station, but the actual audio spectrum itself, 15 kilohertz is the limit for the FM main audio channel. Now if we look a little bit up on the spectrum, you'll see at 38 kilohertz there's a double sideband suppressed carrier modulated there, which goes from 23 to about 53 kilohertz. And that's an amplitude modulated suppressed carrier double sideband modulated signal that carries the left plus the right audio information. Now the reason that it was done this way was because stereo was added after the fact, and they needed to maintain compatibility with the mono FM receivers that had already been produced. So this was the way that they came up about maintaining compatibility. The same as when they added color television, or added color to black and white television, and they needed to maintain compatibility. At least in North America. Over in Europe, they just said, screw it. We'll just kill our old system and come out with a color system, and we'll kind of simulcast for a while, and then we'll just, shut it off. Kind of like what they did when they went to digital here, when they went to high definition. But as far as the analog FM goes, they wanted to maintain compatibility with existing FM radios that were on the market. So this is the way that they came about doing it. They took the left and right information and mixed them together to form the mono audio channel that is broadcast as an FM modulator or frequency modulated signal. Then they took the left and the right information and they subtracted them from each other and came out with the left minus right signal. So the left minus right signal is transmitted centering around 38 kilohertz, and it is a double sideband. It's a suppressed carrier ranging from 23 to 53 kilohertz. Because it's a suppressed carrier, you need to reinsert that carrier in order to demodulate it. So that is done by the receiver itself. But that receiver needs a reference, and the reference is half of the carrier frequency, 19 kilohertz. There's a 19 kilohertz pilot tone that is added to the mono audio, and that is why your mono audio can't get to 20 kilohertz. It has to roll off at 15 kilohertz, because if it were to get any closer to the 19 kilohertz signal, you would actually hear the high frequencies beating with that 19 kilohertz signal. So they actually have to chop the FM radio off at exactly, or chop the audio off at exactly 15 kilohertz. Anybody who's bought one of those cheap FM transmitters to play with their MP3 player or CD player and so forth in the past will have experienced the noise of the pilot carrier or pilot tone beating with the audio on cheap CD players that had crappy filtering. Some of the earliest of the cheap CD players, the Discmans that were out there, actually had very, very little filtering at all, because they figured, okay, well, the subsampling frequency is going to be around 22 kilohertz, so yeah, you're not going to hear that anyway, so why bother to filter it out? Well, the problem was the subsampling carrier that was part of the, when you sample your 44.1 audio signal back, there's always a bit of component at 44.1, and at half of that rate, about 22 kilohertz, that 22 kilohertz noise that was above the hearing range, so you're never going to hear it. The problem was, well, a 22 kilohertz tone beats quite nicely with a 19 kilohertz, and the product was a 3 kilohertz whistle. So if you took a cheap CD player, one that had crappy filtering, and I'm referring to like the first generation of the Discmans and stuff, and you plugged it into one of these little FM low-powered transmitters that had no high power or low-pass filtering on it to cut off around 15 kilohertz, well, you'd hear your music playing, and you had this faint 3 kilohertz tone that ran constantly, and that was due to the pilot signal, the pilot tone, beating with the supersonic 22 kilohertz leak through from the crappy digital filter that some of these, or the lack of filtering that some of these cheap CD players had. All commercial radio stations use what's called a brick wall filter that cuts off anything above 15 kilohertz, and it's a very sharp cutoff, so that there's no chance of interaction between that 19 kilohertz pilot tone and the main program audio. Now, as we continue up the spectrum, you will see that at 57 kilohertz, there is about a 5%, that's 5% of carrier power signal that is used, and that's actually used for the RDS service, which is your data, name of the artist, traffic information, radio station ID, whatever they want to spit out that makes your radio scroll text as you're listening to the radio. That's actually on a 57 kilohertz subcarrier, which wasn't always 57 kilohertz, because at one time that was actually before RDS became popular. That was a third SCA channel that could be used for secondary communications or subsidiary communications. But the main ones were centered around 67 kilohertz and 92 kilohertz. On this little chart here, it shows direct band and audios subcarriers, but that is where additional program audio that the average person could not receive, because their receiver wouldn't tune that in. But if you had a specially modified receiver or a commercial receiver that was supplied by the actual company that was buying that spectrum, because the radio stations would sell a portion of their spectrum for these third-party programs. And what was carried on there, it could have been background music or elevator music, or the doctor's in-office service, or it could be anything. It even could have been stock market. Anybody that wanted to get their message out to an audience, but as a private broadcast, could go to a commercial station and lease a portion of their spectrum, their unused spectrum, for their service. So what I'm going to do now is, many, many years ago, I built an SCA decoder. I was probably only about 10 or 12 years old or something. It was back in the 1970s. I built one out of I think the schematic was actually published in one of those Radio Shack engineers mini notebooks. And I just found this receiver, and it had this thing in it, this SCA decoder in it. I figured I would play around with it and see if it still works. Let's take a look at it. Now, I actually built this into this old Akai stereo tuner, an ATK 02, but I did this at a later time because I built this board much earlier than I had this tuner. I actually had it on a table radio, an old Panasonic multiband radio, which I don't think works anymore, and that's why I ended up putting it into this tuner so I could play around with it, because I used to think it was kind of cool back in the days when, you know, they had elevator music for sure, but there were stations that would have rock music, you know, easy listening or rock music. There was so much stuff on the SCA band. You can see where I've got my dial marked here. I marked it with a pen. These were all the stations that had SCA feeds on them, and you know, so I could just tune it in. And I actually had, at one point, I had an external pot on this thing that I could just tune it to which one I wanted. This is the trimmer now to set the frequency, but this is the little board that I came up with when I was a teenager, I guess. And I don't even know where I got the circuit from. I think I looked this up. I may have looked it up somewhere. Anyways, you can see this is my crude attempt at a regulator, just a resistor with a Zener diode to regulate it, but it's based on an NE565. Now, this is a phase lock loop chip, and basically what it does is it takes the baseband audio, which I'll show you guys in a second, but it takes the baseband audio, which contains the SCA channels, and it's just a phase lock loop, and this adjusts the frequency so you can set it to 67 or 92 kilohertz, and it will demodulate that signal and send it back to the radio. It's not that complex, the circuit. It's actually very simple. The hardest part is actually adding it to the radio, because you need to find a baseband output. And that, in this case, is right here. I just tacked into this little resistor down here. And how I found it is I just used my scope and looked for the baseband audio. This is actually the stereo decoder chip. And this is the input. I believe that's the stereo decoder. Yeah, the IF is over here. This is the stereo decoder chip. And this is the input to it. So, same information is going to the stereo decoder, but this is only tuning in the 38 kilohertz stereo information and providing you the left and right. So we just tapped into it to take it off. I'll turn on the scope here and we'll take a look at what I'm talking about when I mention baseband audio. So I've got my scope clipped to my multiplexed output. Let's take a look at what we're seeing on the scope here. So this is our baseband audio, and this is actually a mono station that we're listening to here, which has no subcarriers on it. If I tune down to I'll tune down to my test transmitter if I can find it. And now you'll notice, you see the extra information here? If I were to turn off the sound, it would look like there was a carrier. So if I go and unplug the memory stick that's playing on that thing, okay, now you can appreciate it. This is the stereo difference signal. If I crank up, you will see there's a carrier there. That's the 19 kilohertz pilot tone you're probably seeing there. Because the 38 kilohertz difference signal, there wouldn't be anything on that right now because I'm not actually transmitting anything. So what we're seeing here, this is going to be the pilot tone that's present. If I start playing music again, we'll plug the music back in. Okay, now what you're seeing is the baseband audio as well as the stereo difference signal, which is also in that mix with that pilot tone. If I tune to another station, you see that this station This is the mono station. We don't see that pilot tone that we see here. Here we see the pilot. That's the pilot. If I go to the next station, this is actually a mono station. No pilot tone. Next station up. You should see a pilot tone on this one as well. This is a much louder signal. It looks like, but there's the pilot tone. You can see it. Now, as I go up the dial, I'm going to go to the station that has SCA. And you can see, here's the carrier. This is a mono station, but this has got an SCA. In fact, it's the only one left that has SCA. And of course, the signal is much weaker than the program audio. But right now, there's one station left that has SCA. There's a little cleaner view of it. Right, there's the baseband audio, and you can see the carrier in the background. As I increase the or decrease the scan time, you can now see the carrier that's there in the background. Anyway, this is a 67 kilohertz signal, and it's to say if my SCA decoder was working, you'd be able to hear it. The audio level is much lower, obviously, than the program audio. I think it's 12% of modulation. It's not much, but there's another way to receive the signal, and I'm going to demonstrate this. And rather than fix this SCA decoder board, because there's not really anything worth listening to on SCA these days, but I'll show you another way to receive it, and then we'll go in and we'll see if there's any other stations other than this one. I know that this one does it. This is the CBC French service, and they have an SCA service. What I'm going to do is I'm going to connect a wire to this thing, and then I'm going to take it in the house into my shack, basically. I'm going to hook it up to my shortwave radio, because yes, you can tune this in if you have a shortwave radio, or in this case a long wave radio, that can tune down to 67 kilohertz. I can go down to 30 on my old Kenwood radio. All you gotta do is put it into FM mode and basically plug it into the antenna input and tune it in like it's a radio, because it is essentially just an FM carrier that is modulated on top of the existing audio. So I'm just going to solder on this wire for ground. And hook it up to my capacitor that I put in here just to isolate, so that I'm not connecting the antenna directly to the output of the discriminator. And we're going to move in now, and we're going to hook this thing up, and I'll show you guys how to tune this stuff in and what's there, and we'll scan up and down the band and see if there's anything else. I think there's only the one station, if I remember correctly. There's just the one station that has SCA on it now, so we'll go and take a quick listen to it. Okay, so here's a shot of the front of my old Kenwood TS690 ham radio, and it will tune FM down to down to 30 kilohertz and AM and sideband and everything. I've got it tuned for 67 kilohertz, and I've got the antenna, the wire that I attached to the baseband output from the tuner is connected to the antenna on the radio. So I'm just going to turn up the volume here a bit, and we're going to go through the band. I've got the tuner just sitting here beside me. I'm just going to scan through the band. You're going to hear noises and stuff, because you'll hear the RDS data from like that. You're going to hear some of the RDS data from stations that have RDS. As I tune through the band, though, if I come across any SCA, we're going to hear it. Oh, there's one right there. That's that French station. But this is not French music. This is actually, I think you can guess what it is. You got it. It's I think it's a Punjabi station that is carried on 67 kilohertz. Yep. And that is it for the entire band. One station. That's why I'm not in any hurry to fix that SCA decoder, because there's not really anything to listen to. If I go to the other frequency, which was 92, they don't have anything at 92. But we can scan the band and see if there's anything on any of them. Sounds like there's a carrier on that station. Definitely a carrier there of some type, but the audio is very, very low. Now here's something interesting. This is one of the powerhouse stations that has HD audio. Listen what happens when we tune the carrier, tune the frequency up. There we have a carrier at 145 kilohertz. We have another one at 224. And we have another one at 310. And if I go to other modes, obviously this is digital data, so we're not going to hear anything. Just a buzz. There it is. There's the three carriers that they have. That's going to be tuning in the difference signal. Which is at 38 kilohertz. So that's the stereo difference signal for the actual FM station that I'm able to pick up there on 38 kilohertz in sideband mode. Neat, huh? And of course, signal strength makes a big difference, right? If your signal's not strong, it won't come in very well.
123 Delta, next to Wheel Travel. समझ नहीं आ रहा कि क्या लूं। हम उन्हें रेडियो पीटीमेसी का होम रेडियो क्यों नहीं गिफ्ट कर सकते? आखिर RFM कनाडा का अपना 24/7
Okay, now that I'm back out into the shop, I'm now going to return this radio back to, I had it on the DX local switch back here, but that's okay, we'll take that out. I'm going to return this radio back to factory. I'm going to remove this little decoder board that doesn't work, and we'll put this radio back as an FM AM radio. The reason why is this is one heck of a good tuner. You know, check out the tuning capacitor on this thing. This radio is so sensitive, this tuner. It's probably one of the best radio tuners that I've used as far as sensitivity goes. Even on the AM band and the FM band, it just pulls in signals that a lot of other tuners just didn't get, which was typical of the receivers back in the early 80s. And, you know, in the 70s and 80s, these things were just fantastic as far as receiving goes. I mean, look at the big flywheel here so that you can spin the dial and it just keeps going, right? Sign of a quality receiver. But anyway, I figured I'd show you guys SCA, how it works. Yes, it's still in operation after all these years. I didn't expect to actually pick up anything with it, but the easiest way obviously is just to take your detector output and just plug it into a shortwave radio that can tune down to 67 kilohertz. That's the easiest way to do it, and actually you get the best quality because you're getting a much better receiver that's able to tune that signal in. Anyway, thanks for watching. We'll catch you again real soon. Bye for now.